Welcome to This Explainer. Today, we're unpacking something super fascinating, the architecture of What's PayState. You know, on the surface, it looks just like your everyday WhatsApp chat. But underneath, it's hiding this massive, highly engineered financial execution network. We're going to break down exactly how you build a rock-solid financial ledger system natively inside a messaging app.
All right, let's just dive right into this stark reality. Right now in South Africa, there are literally 11 million unbanked adults, and they're operating in a heavily cash-dominant informal economy. To put that into perspective, we're talking about 2.5 million informal traders processing billions of rands in physical cash every single day, and they're doing this with almost zero digital infrastructure to back them up.
So this naturally leads us to a pretty massive question. How on earth do you build digital financial infrastructure in a place where physical cash absolutely rules? Like, how do we digitize billions in daily cash trades without forcing these users to download complex apps, figure out new interfaces, or buy clunky point-of-sale hardware? Well, the answer is actually pretty elegant. You meet users exactly where they already are. And for 93% of South African smartphone users, that place is WhatsApp.
Let's start with Section 1, the one-message solution. This is really the tip of the iceberg.
Now, the core value proposition here comes down to one word: friction. In the old way of doing things, informal commerce practically runs on endless manual verification texts. You know the drill. Merchants constantly messaging customers, "Hey, did you pay? Can you send me the proof of payment?" It's exhausting. But the new way, it transitions that entire massive friction point to a single automated, stateful OZO EFT link. One single message, automatic confirmation, and absolutely zero human follow-up required. A real game changer.
And what's so cool is how totally frictionless the flow is for the user. Step 1, the user simply sends a text string, something like pay 500. Step 2, the system instantly parses that intent and fires back a secure OZO payment link. Step 3, the user pays via standard electronic funds transfer, and boom, an automated webhook instantly flips the transaction status to paid. The user experience here is just pure communication. There are no digital wallets to top up, no apps to update, just a seamless, everyday chat thread.
But to make that simple interaction safe and scalable, we need to drop down into Section 2, beneath the surface, the phase technical architecture.
Now, this architecture wasn't just built all at once in a vacuum. It actually scaled alongside demand. Week 1 was literally just a basic 3-file Node.js app living in memory, talking to the OZO payment API. Then, by week 2, the MetaCloud API bridge gets added, so real WhatsApp messages finally start flowing. Come week 3, they add persistence using SQLite and a queue system called BullMQ. And finally, by month 2, the whole thing evolves into a fully fledged PostgreSQL database running a strict double-entry financial ledger. Honestly, it's an absolute masterclass in saving money and building only what you need exactly when you need it.
To prevent fraud and stop system crashes, the whole architecture relies on 4 non-negotiable design rules. First, before trusting any data, every webhook's SHA-512 hash absolutely must be verified using a private key to ensure it's legit. Second, because payment gateways will inevitably send duplicate success messages, handlers must be idempotent. Otherwise, a user could easily get credited twice for just one payment, and we definitely don't want that. Third, and this is super interesting, an account balance is never actually stored in a database column. Instead, it is always dynamically derived from immutable ledger entries. And finally, the system always returns an HTTP 200 success code back to the payment gateway. Even if internal systems throw an error, you have to return that 200 just to prevent the gateway from infinitely retrying and totally locking up your resources.
Now, what truly separates this from your run-of-the-mill messaging app is the reconciliation engine. Think of this as an automated auditor that runs via a cron job every single night at 2 a.m. South African Standard Time. It methodically compares the internal PostgreSQL ledger against OZO's external gateway records. And if there is even a 1 rand mismatch, it raises an alert immediately. Because finding a 1 rand error at 2 a.m. means you're catching a bug or a fraud attempt. Finding that exact same error 30 days later, well, that's a regulatory disaster.
You also have to consider the queue system, which here is powered by BullMQ. Now, before you hit real transaction volume, queues might seem kind of optional, but here, they're mandatory. The queue acts as a critical shock absorber. Let's say the OZO API is being super slow, or the system crashes right in the middle of a payment. The queue ensures that transaction doesn't just disappear into the void. It safely backs off and retries. Plus, it ensures that all writes to that double-entry ledger happen consistently and in perfect chronological order.
All right, now that we understand the open source tech stack, let's pivot to Section 3, Economics and the Real Business Moat.
Take a look at the leverage of this system at scale. It's honestly incredible. By month 12, projections show 10,000 active users, driving 52.5 million Rand in gross merchandise value every single month. And because the underlying infrastructure scales so cheaply, using serverless databases and open source tools, the gross margin expands to a massive 75%. The entire model is specifically designed from the ground up to reach break-even by month 7.
This creates a wildly aggressive growth trajectory. You start with a seemingly tiny, flat 3 Rand fee per EFT transaction, right? But then you stack that with 3 to 8% margins on airtime and utility resales, and it scales up dramatically. Month 1 brings in just under 5,000 Rand in revenue. By month 6, shoots to 300,000. And by month 12, it's projecting 1.8 million Rand in monthly revenue. It literally takes low-value, high-frequency cash movements and turns them into a massive, highly profitable digital revenue engine.
And get this, pulling the whole shebang off only requires a lean, highly disciplined 7-person team. The equity structure is tightly aligned with operational success too. 60% goes to the founder, 20% to the CTO running the architecture, 10% to the operations director managing that crucial on-the-ground agent network, and a 10% option pool. There are no bloated departments here, just a highly focused execution squad operating on a strict hour-by-hour schedule every single week.
The system's growth relies on this really clever viral loop, which honestly is the ultimate business mode. Step 1, a merchant sends a WhatsPay state link. Step 2, the customer pays it via Ozo. Step 3, the customer lands on a confirmation page carrying the WhatsPay state brand. And then step 4, that customer, who, keep in mind, might be an informal trader themselves, thinks, wow, I need this for my own business, and they sign up. So the transaction itself is the advertisement. It turns end users into brand new merchants with literally zero customer acquisition cost.
I want to leave you with this provocative thought that really summarizes the entire philosophy of this explainer. Replace human follow-up with a stateful link. You see, true financial innovation in emerging markets isn't always about building the flashiest, most complex smartphone apps. Often, it's about executing relentless operational and financial discipline behind a messaging interface the user already knows and loves. It's about making the highly complicated completely invisible. So think about the friction in your own daily workflows. How many manual back-and-forth conversations could you replace with a single stateful link?